Hey, math people. Another year, another glorious season of SAT. Spring is in the air, but SAT is on the mind, hopefully, for all the juniors out there. Yeah, so another math SAT video coming at you. This time around, we're going to be looking at this common theme, this common type of question that I see on every single SAT that I ever have taken with my juniors year in, year out. So what is that type of question that I always see? That question type is modeling with mathematics, which happens to be a common core standard, math practice standard, number 4, if you're curious about that. The reason why I bring that up is because, well, if we consider it a standard, well, then obviously a standardized test is going to ask about it. So what does this idea of modeling with mathematics mean? It just means, well, okay, if you're given a story or a text or some sort of scenario, can you convert it to an expression, system, or equation? So what I've done is I've randomly chosen practice test number 8 on College Board's page, and I just scrolled right on through it. I didn't do any of these problems. This is actually a newer one. I think they uploaded this one like a year or so ago. And I just looked for questions that did exactly that. So I just simply scrolled through this practice test just because I'm so very confident that the SAT is going to have question types like this. And I found 10 questions. I found 10 questions that have to do with this idea of modeling with mathematics. So those questions are right here. So I encourage you to pause the video, download this practice test number 8. It's in the description, or you can find it on College Board's page, and to try out these 10 problems on your own before you watch this video. Since I found a whopping 10 of them on just one practice test, you're gonna obviously see questions like this on the real deal. Okay, so let's get to it. So I'm just gonna scroll right on through, scroll past the reading English section, so pay my dues and respects to the reading test, because ultimately the questions we're gonna do today have to do with reading. So really it's kind of ironic that we're just kind of passing through this stuff. So actually I'm gonna scroll faster. Yoink. Okay, so we're going to start with the non-calc questions. So we're actually going to start with 3.5. So here's the non-calc. We have 25 minutes for 20 questions. We're going to scroll. So number 5 happened to have been the first question that has to do with this idea of taking text and kind of transforming it to some sort of expression. Okay, so my tip with these questions. First off, look for them. Like, keep this idea in mind as you're taking the SAT. There are going to be quite a few of these. Just simply keep an eye out for them. Be wary that they exist. That's it. That's my first little tip. Let's look at this question here. So I'm just, right off the bat, I see that there's words. SAT has a lot of reading. So I'm looking at number 5. Here, I'll even kind of just point where I'm going. Looking at number 5 here, I see that there's words. It looks like I have to write some sort of expression at the end of the day with W. So let's read through it. So it's saying the width of a regular dance floor, all right, is W feet. The length of the floor is 6 feet longer than the width. Which of the following expresses the perimeter in feet of the dance floor in terms of W? Okay, so they're trying to make this somewhat topical, I guess. It's on a dance floor. Okay, so what we want to do, we want to look for, what do they really want at the end of the day? What is that shell? What is that default equation we want to write, or default expression we want to write? So it's asking for a perimeter, so I know it has to do with perimeter, and it's a rectangle, so I know the perimeter of a rectangle. Perimeter is just you add up the sides, right? So there happens to be an equation for a perimeter of a rectangle. It's 2 times the length plus 2 times the width. All right, so we're writing this in terms of W, so this 2W is good to go. So I should clarify, I didn't do any of these questions ahead of time. So you can see that as ill planning, but I like to think of it as you get to see how I think as I work through some of these problems. Okay, so the length of the floor is 6 feet longer than the width. We can use that to our advantage. I'm just gonna rewrite this right down here. I know that the length is just the width, but just like 6 feet longer, man. So it's just W plus 6. Take that expression, plug it into L. And we can just simplify that and be done. If you'd like to see the math for that, it would be 2 times the W plus 6, and then plus 2W. Distribute that young 2. We got 2W plus 12 plus 2W. I'm already jumping to the answer there. 2W plus 2W is 4W. Right off the bat, I know it's going to be B. So we started off with a pretty nice baseline problem. SAT likes to put some of the easier questions a little early on, as in like the first few questions of the multiple choice for both 3 and 4, the 2 tests. What we did was we considered some sort of a shell of what it is asking for, and then we plugged in the values that were necessary to simplify to their answer. You're going to see more of this as we go. Let's try out the next one. So the next one they ask for is 13. The one that I asked for is number 13. So number 13 is a little like this too. So number 13 here, another model with mathematics S question. I told you earlier to keep an eye out for question types that are in this fashion where you have some sort of context and then you have to write a model thereafter. Take a look at 13. So if we look at the answer choices for 13, they all pretty much look the same, except there's subtle differences between them, in which case I notice that these are all linear. These are all just taken on the form, hopefully you can see this if I write it down, y is equal to mx plus b. They're lines. So without even looking at the question itself, I know it has to do with the line. And we're just trying to figure out, well, okay, what's the slope? That's all we're looking for. What's the slope? So let's do that. Let's find the slope. Let's use this as a shell. We're just filling in the meat. Oil and gas production in a certain area dropped from 4 million barrels in 2000 to 1.9 million barrels in 2013. Assuming that the oil and gas production decreases at a constant rate. Okay, so keyword constant rate. SAT will always, not always, but it frequently will tell you when something's got a normal slope. Which of the following linear functions, it even tells you linear, best models the production in millions of barrels T years after 2000? That's kind of important. It's just saying after the year 2000. Okay, well, I have 2 ordered pairs actually, really. So I have the ordered pair here. So after 2000, if you find the difference from 2000 to 2000, it's 0. So my first ordered pair is going to have to do with this 0 years after 2000, comma 4 million barrels. And my second ordered pair, I got another one. It's this 1.9 million barrels in 2013. So if we write that as an ordered pair, same exact idea. So 2013 is 13 years after 2000, and we're at 1.9 million barrels. So I realize I probably just put that ordered pair in a spot where you can't see. So I'm going to put it right here, 13, comma 1.9. Okay, so we're just taking these ordered pairs and we're simply finding the slope. That's all we're doing. So I know my slope equation is change in y over change in x. My change in y, we'll do the bottom one first. It's going to be 1.9 minus 4 all over 13 minus 0. And this makes sense. You're going to get a negative number up top, and that's because it's going down. So 1.9 minus 4, that's a number, 2.1, negative 2.1, right? Negative 2.1, and then down below 13 minus 0 is just 13. So this is my slope. So this is a 13 down there. I know that my head's cutting it off. We noticed that these slopes are not that slope. They're different, but not really. We can just actually move the decimal place over 1. So I'm going to sneak that over here. If I move the decimal place over 1 to the right, we get negative 21. And if I move this decimal place over to the right one from 13, it's 130. So my slope is negative 21 over 130. Let's just find it. Here it is. So we're just filling in the meat of this shell of a linear equation. Y is equal to mx plus b. My slope here is negative 21 over 130. And that's just choice C. Just checking with my key there. Although I didn't do these, I do have a key. So cheating a little bit. Okay, the next one I said that is similar to this idea of modeling with mathematics is number 19. Is it a free response? It is a free response. Okay, so kids are like randomly afraid of free response. So you like bubble in a number from like 0 to like 999 or 9,999. And it's decimal answers. If you obtain a decimal answer with, decimal answers are good, but negatives are not, right? I think the answer choices are from, you can't even input a negative. The answer choices are from, I guess, 0 to 9,999. So if you get a negative number, you did something wrong. Okay, so let's read this one. So we actually can't work off the answers here, obviously, because it's free response. It says, a startup company opened with 8 employees. The company's growth assumes that 2 new employees will be hired each quarter. 2 new employees will be hired each quarter. Okay, we may not have to use that, but every 3 months it tells you. Okay, so it's giving you a lot of info for the first 5 years. First 5 years, I guess. If an equation is written in the form, okay, so y is equal to mx plus b. Hello, anyone? They just said a is your m here, whatever. To represent the number of employees, y employed by the company x quarters. Okay, so we are going in x quarters. After the company opens, what is the value of b? This is just secretly asking for the slope intercept. That's all it's asking. So here's that shell. That shell is y is equal to mx plus b. We're a company that starts on 8 employees. So actually, that's just the answer. You plug in 8 for your y-intercept, your starting value, you're done. I guess if we were to just, for whatever reason, keep going and finish this model, it does give you that every 3 months, every quarter, you get 2 people. So I guess a is equal to, or your m value is equal to 2. We have an equation here of simply 2x plus 5 is just saying, hey, or 2x plus 8, sorry. It's just saying that that's the starting value. That's it. Actually, they gave you a little bit more information than you needed here. All you need to know is that in mx plus b, b is your starting value. It's your starting point. You open with 8 employees from the very first sentence. So on your little grid, so this would be like a free response question. You would have like a few different, I'm trying to draw like a grid, I guess. I don't know. I don't know why I'm doing this. But you would just put in 8 in the last cell. I'm pretty sure you can put 8 anywhere, but you would just simply bubble in 8, and then that's it, and then you'd move on. Okay, next one. Looks like we're moving on to test 4, the calculator, so we can actually use a calculator now. And it looks like number 1. Oh boy. Okay, I read number 1. I guess I secretly did do number 1 because number 1, this is what I call a time saver. So number 1 technically follows the criteria of this video, this idea of modeling with mathematics. Take a real scenario and model some sort of expression, equation, or system based off that idea. I mean, you probably already did it while I was just rambling on there. 1 pound of grapes costs $2. At this rate, how many dollars will C pounds of grapes cost? So I don't know, man. If you buy like 1 pound, you spend $2. If you buy 2 pounds, you spend $4. Yeah, it's as simple as this. So you're just multiplying here. So the answer is just very clearly A. This is a classic time saver problem. This problem is designed for you to do in 10 to 20 seconds. And what you're supposed to do is you're supposed to steal that time, that allotted time per problem from this problem and distribute it to the harder ones. So what do I mean by that? The SAT, this one, it looks like we have 55 minutes for 38 questions. That's approximately 80-something seconds, I think, per problem. And if you do distribute it evenly, technically this problem should take us 80-something seconds, but obviously not. What we're doing here is we're doing this in roughly 10 seconds, and we're robbing that extra 70 seconds and distributing it to the harder ones down below. So with these problems in mind, my best advice is to move swiftly, not quickly, swiftly. So actually read the whole thing. You don't want to get a problem like this wrong because it is, maybe I should double check. Yeah, it is literally as easy as it looks. So you don't want to accidentally do, oh, it's 2 plus C and get it done in 8 seconds. Great, you saved a lot of time, but you got the easiest problem on the SAT wrong. So let's do number 6 now. So let's scroll to number 6. Okay. Oh, I don't know if I can fit this whole problem. Hopefully I'm fitting the whole problem. Right now, before we even read the problem, first off, it's a lot of reading. Yeah, it's what it is. We're looking at specifically the reading problems, I guess, to some extent. I noticed that all the answer choices pretty much look the same, right? So as far as like determining what the shell of the problem really is, you're staring right at it. All these answer choices are the same. What they do is they just ultimately, A is a little different, so A is probably not going to be right, most likely. So if we look at what's going on here, we flip-flop the coefficients. Here we have a 40 in front of B, but then a 75 in front of it here. And here what do we do in this choice D? Looks like they just, here we have that 19,000 value. in the first equation, and here it's at 350 value. So clearly we're just jumbling up the numbers. We're just trying to figure out where do the numbers go. So very clearly, this is the shell. We're just trying to figure out, well, what goes in front of B and L? What are they equal to? Let's read it. 2 types of tickets were sold for a concert held at an amphitheater. Tickets to sit on a bench during the concert cost $75 each, and tickets to sit on the lawn during the concert cost $40 each. It's very common practice. Okay, so organizers of the concert announced that 350 tickets have been sold and that $19,250 had been raised through the ticket sales alone. So it's saying which of the following systems. Obviously, B is equal to bench and L is equal to lawn. Okay, so we're just filling in the blanks. I know that 75 is associated with bench tickets, so obviously the 75 is going to go right on here. I know that $40 is associated to the lawn tickets. I know that $40 is going to go right on here. And it's here we're talking about the money equation. So if we look at the answer choices, A is out the door. A is making no sense. You wouldn't take the product here. That doesn't have any real value. If we look at the choices here, we're trying to figure out, well, they're trying to jumble up what it's equal to at the end of the day. This top equation represented the amount of money that they made. So if we're going to use our final values here, so I mean, we had 4 values in total, right? And we have 4 blanks. We used the 75. We used the 40. Here we have 350 and 19,000 in terms of money. 19,250. Obviously, with that said, since I'm dealing with money in this top equation, we have money as our final kind of answer here. This is going to equal to 19,250. This bottom equation right here actually just represents just attendance, total attendance. You add up everyone sitting on the benches with everyone sitting on the lawn, and you get the total attendance, which is 350 people there. So we're just plugging in numbers to this shell. That's all we're doing. So if we look at the choices here, this one's obviously wrong because that's the attendance, and we're dealing with money and attendance at the same time, so that top equation's wrong. What do they do? This one looks good. Here, what do they do wrong? They switched the 40 and the 75 up. So obviously that's not right. They just didn't read it right. They associated the wrong numbers with the wrong descriptors. Here we just have D as our final choice. We have 75B plus 40L is equal to that 19,250. And then total attendance, B plus L is equal to 350. Let's look at another. Number 12 is apparently very similar to this idea. Okay, this is good. I like problems like this. Again, it's the same sort of idea, but this time around, I'm just taking a look at it. We have an inequality in play, some sort of system of inequalities. All of these look roughly the same. We're just trying to figure out, well, which one is the right one, right? So just looking at the answers, just not even looking at the problem, I notice here that the expressions every single time are the same. We're just looking at the inequality sign. We're just looking to flip the inequality sign. So like here it's a less than, whereas here it's a greater than. We're just trying to figure out which one's correct based off the story. SAT loves problems like this. Loves them. This type of problem I've answered so many times before. I have not answered the one with Roberto, the insurance agent, but I've answered this type of question dozens of times. The SAT will ask you a question like this, almost with 100% certainty, like really, really high certainty. Okay, so let's just read through it. Very clearly here, we're just trying to figure out, is it a greater than or a less than? That's what we're trying to figure out. So Roberto is an insurance agent who sells 2 types of policies, a $50,000 policy and a $100,000 policy. Last month, his goal was to sell at least 57 insurance policies. Okay, so I like that at least. While he did not meet his goal, this was super mean. Who wrote this problem? This was mean. This was very mean. This was very mean. Because it's saying at least 57 were sold. So if we think, what is at least 57? Well, 58, 59, 60, numbers that are greater than 57. But he didn't meet his goal. So it is now numbers that are less than 57. So this was super mean. Wow. Okay, so we have to find the ones that are less than 57. So this guy's out the door. Wow, that was so mean. This guy's out the door. We're already looking at just choices A and C. Can't get over this. Okay, whatever. The total value of the policies he sold was over 3 million. Okay, so I know that that's this value here. Which of the following systems of inequalities describe that? Okay, so the possible number, X, it has to be associated with 50,000, and Y has to be associated with 100,000. So he sold over 3 million. So it is greater than 3 million. of my two choices here, here's my greater than. That's not a choice. So of my two choices here, here's my less than, here's my greater than. I can remove the less than option. And it looks like the only one without an X cut through it is this choice C for 12. So wow, really read the problem, even though I kind of skipped the reading at the end there. But usually the SAT, the last sentence is like describing the variables. I've noticed that at least. So they say like, which describes X is the possible number of $50,000 policies, Y possible number of $100,000 policies. Usually that last sentence is just describing the variables. So I know I skipped it, but the point of this is to read everything, because this was super mean to throw this in here. He's saying at least 57, so your eyes might be locked on that, and you think, okay, greater than 57, got it. But he didn't meet his goal, and they snuck that in, and that was actually very, very important to the problem. So read it through. Okay, what's another one? We got number 20 now. So let's scroll to number 20. Whoa. Oh, I've been scrolling with my mouse. Let's find number 20. Okay, so looking at number 20. Okay, this one's strange because the answer choices all look kind of different. We're used to thinking, okay, is it y is equal to mx plus b? Is a perimeter, an equation, an expression that's kind of easy to draw back to. Right off the bat here, it doesn't look like we have that going on, so let's kind of read it through. The average annual cost for a certain home is $4,334. The homeowner plans to spend $2,500 to install a geothermal heating system. Okay, so I know I'm going to need that value in this one. The homeowner estimates that the average annual energy cost will then be $2,712. Which of the following inequalities can be solved to find t? And this is where they just describe the rest of, they describe the variable to you, the last sentence, kind of what I referred to in the last problem. The number of years after installation at which the total amount of energy cost savings will exceed, okay, I like that word, exceed the installation cost. All right, so we're trying to figure out when, so every year we're saving money with this, I guess, geothermal heating system. We're trying to figure out after how many years will this $25,000 investment finally pay off? So you're normally paying this much, this $4,000 amount, but then after you get this thing, you're paying actually only this much. So every year you're saving the difference. So keep that idea in mind. You're saving whatever the difference is between these every single year. Eventually, after enough years, your total difference each year will exceed this $25,000 amount. So this one's weird because it has no default shell. I suggest just looking off the answer choices and then working off that. Immediately, I noticed that A and B are pretty much the same, except they flip the inequality. So that's good to know. Let's look at C. So C is saying you take the cost of this heating system, you subtract off the average. That's greater than, this doesn't make any sense. That's greater than how much you spend every year for T years. No, that just doesn't make sense. So I think the point of this problem is it's going to give you, you have to just interpret the setups. Like this setup makes no sense. And actually I would imagine D is the same thing. So it's saying, yeah, I like how this is isolated. That's good though. Take 25,000. When is it greater than? That's already wrong because we're trying to figure out when how much we're saving each year is going to exceed it. So that's already wrong. Is greater than the ratio? No, that ratio is not going to be helpful multiplying it by the number of years. So that's another weird choice. Very clearly here we're battling between A and B. So it's just the sign. So let's think about what these statements mean. This is saying that investment of $25,000 is greater than the difference each year times the number of years. So that makes sense. Here we're saying it's greater though. We want to figure out when that difference per year is going to be greater. We're trying to figure out when that is the bigger number. So actually we're trying to figure out when this thing is bigger. Therefore, B is our answer choice. So yeah, no real math here. This was just kind of reading. This was a reading problem. We just did a reading problem right now. Go reading. You'll actually notice for quite a few of these, I haven't done that much math. Some of them I did. I had to like compute the slope or something, but not for all of them. Some of these I just didn't do any math. It was purely a reading problem. Okay, so there's another problem type like this, number 23. Okay, so now we're looking at number 23. Without doing any reading of it at all, I just noticed that these four equations all pretty much look the same. They're all exponentials. So an exponential is going to look like y is equal to a, which is usually the starting point, times b, which is like that growth factor or decay factor, to the power of x. So x might be every year or something like that. So I know that this is my shell, and I'm trying to figure out, well, what are the inputs and what do we have to do? What do we have to manipulate to them? So here we have the equation above models the number of members, m, of a gym, t years after the gym opens. Okay, so here this gym just happens to start at 1,800 members. That's a lot. And it goes up by a factor of 1.02 every year. This is 2% growth every year. So that's good to know. Of the following, which equation models the number of members of the gym, Q, quarter years after the gym opens? Whoa. Okay, so they give you this model. We're just converting T, so T represents years here, to Q, which represents quarter years. Okay, looking at the answer choices, they pretty much all look the same. There's no reason for you to manipulate this growth factor. I think they're trying to trick you into thinking it's some sort of compound interest problem or something like that. These are already gone. That's not the case. We're just converting our unit here. We're using quarter years instead of years. That's all it is. So we're actually not changing the model at all. So really, ultimately, the question just simply is, do we divide quarter years by 4 or do we multiply quarter years by 4? I don't know. Let's just play with the scenario. Just play around with the scenario. Let's just pretend. Let's just pretend I had, I don't know, 8 quarter years. So let's pretend I had Q is equal to 8. If we think about if Q is equal to 8, what would you have to do to get how many years that is? Well, you'd have to take 8. You'd have to split it into its 4 quarters. You'd have to divide by 4. 8 divided by 4 is 2 years. So what did I have to do to get from quarters, so 8 here represented those quarters, to years? The math I just performed was divide by 4. So with that said, obviously here, that's my choice. Divide by 4 is what we have to do. 2 quarter years to get to years. Yeah, it's really tricky. When writing, this is like a common skill to do when writing systems in like junior year. You have to write pretty complex systems of inequalities. It's called linear programming. And a lot of kids mess up on this very thought right now. My suggestion is to plug in numbers, to play around with like inputs. If you had 16 quarter years, that's just 4 years. So what did I just do right there? I divided by 4. Kind of trippy. So that was the battle, the struggle in that guy. The next one I said was 25, so I didn't have to do much scrolling. So we got 2 more left. So here they give you a table, looks like, but if we look at the answers very clearly here, we're using some sort of mathematical model. It looks like these are all lines, right? So I'm gonna actually put down, y is equal to mx plus b. I hate this box. I'm gonna put y is equal to mx plus b here. Okay. I know that it's a linear model because literally my only choices are linear models. Okay. It says the table above shows the population of Greenleaf, Idaho. Oh gosh, this is so boring. For the years 2000 to 2010. If the relationship between the population and the year is linear, okay, so it's just telling you it's a line, which of the following functions P models, so modeling with mathematics, the population of Greenleaf T years after 2000. I like it when it does stuff like this, like after year 2000. Where do I want to start? Obviously, I'm going to have to find the slope, but I want to start with the models here. It's saying T years after 2000. So actually, 2 of these answers are just wrong. They're baiting you into thinking that they're right, but they're wrong. So these 2 right here are in point slope, C and D. A and B right here are in slope intercept, which is this mx plus b. So T represents years after 2000. So why would you subtract 2000 from that? Because 2000 years, you would go back to like year 0. And that's very clearly not what's going on here. So C and D are out of the picture because T already represents years after 2000. You don't have to do this minus 2000 idea. So we're just trying to figure out what's the slope, what's the starting value. That's it. Very clearly here, we have the same y-intercept for both of these, which makes sense because after the year 2000, if 2000 is 0 years after the year 2000, we just start at 862. Now we just have to find the slope and we're done because obviously here these slopes are different. 1.6 is different from 16. So it's change in y over change in x. So I'm going to do 846 minus 862. Our population is going down, another negative slope. And then this is going to be over 2010 minus 2000. This math is easy. 2010 minus 2000, that's just 10. 16 over 10, that's just going to be equal to 1.6. I should have clarified here, these were negatives, right? You're going down by 16. So if you were getting ready to write a comment, I just caught the mistake. So it's negative 1.6. So very clearly here, our answer is A, not negative 16. Yeah, so that's another, this time around they gave you a table. They haven't been giving us, actually this is an easier version of one we already answered. Because the other one we already answered, we had to like extract the ordered pairs. Here they just gave it to us. So this is an easier version of one that was already answered. We are given a scenario, we're given a story, and we're modeling that story with mathematics. Okay, the last one like this on this test. I mean, this is pretty substantial. 10 problems are like this on this test, and it's another multiple choice, which is good. All right, so again, just without even reading it, all these answer choices very clearly here, we're trying to determine, okay, what is my model? Something maybe that's not as clear, A and B are linear. Just looking at, it's the slope and then, sorry, the slope's here and then a y-intercept and a slope. This is just mx plus b, but it's just flipped around. I think the last one was like that. And these two are not linear. These are exponential because the exponent is a variable. Okay, so let's try to figure out, is this going to be linear or exponential based on the problem? So a photocopy machine is initially loaded with 5,000 sheets of paper. We start on 5,000. Okay, that's all of these actually represent that. If we think about linear, that's y is equal to mx plus b. If we think about exponential, I already wrote that default model earlier. That is a times b to the power of x. A here, it's funny how this works out. This b value is actually the starting value. This a value here is actually the starting value. It's kind of flipped. So far, so good. All these models satisfy with the 5,000. That's not what this problem's asking. The machine starts a large job and copies at a constant rate. Done. Half the work is already done for us. Constant rate, already off the bat, with confidence, hopefully. Yes, with confidence. Just checking the answers there. We can eliminate C and D. These are gone. This is not exponential. We have a constant rate of change, which is linear. So done. We're already isolated to A and B. We're just determining that the secret question really is the slope negative 20 or is the slope negative 75? That's all it's asking. After 20 minutes, it has used 30% of its paper. So I know I keep stopping here, but the math teacher, they're trying to bait you here. The math teacher inside of me sees the trap. They're saying 30%. Usually when you see a percent, that is exponential. So if you like lose 30%, if you're initially at 100%, you're at 70%. So they're trying to bait you into thinking that this is the answer here. But this is not exponential. This is linear because it gives you constant rate. So there is a rhyme and reason here. That's all I'm trying to communicate. Which of the following equations models, and this is the descriptor sentence, models the number of sheets of paper, P, remaining in the machine m minutes after the machine starts printing. Okay, at the start, 0. Oh, I think I'm off the paper. At the start, we're at 0, 5,000. At the very beginning, we're at 0, 5,000. 0 is time, so 0 seconds have gone by, or 0 minutes. We're at 5,000 sheets of paper. After 20 minutes, we lose 30%. So this is going to be 20, so we have to think here, what is 30% of 5,000? So I know that 10% of 5,000 is just 500. So that times 3 is 1,500. That's how much I've lost from the initial 5,000. So I'm actually at 5,000 minus this 1,500. I'm at 3,500 sheets of paper at 20 minutes. So yeah, that was mean. That they had you do a little bit of math to figure out what this Y value is going to be. But you were able to find it. You know, you just take 70% of 5,000. That's all it's asking. And of course, we're going to end the day with finding the slope because we've done that. It's like the only math we've done all day today. The SAT loves linear problems. Most of the questions on the SAT are going to be linear, even though this is a curve right here. But a lot of the questions where it asks very specific aspects of the problem, they're usually going to be lines. Okay, so I just cleared up some space here. Just finding the slope. So let's do change in y over change in x. So I will do 3,500 minus 5,000. So that's my change in y. And then my change in x would be 20 minus 0. That's some easy math there. This is going to come out to be negative 1,500 over 20. So yeah, I could sit here and do long division. This is the calculator portion. Obviously, it's just faster to check with the calculator. The calculator tells me that this comes out to negative 75, making choice B my final answer. Thus concludes my little video on this type of question, modeling with mathematics. So taking a context, again, I know I keep repeating it, and then writing a model from it. SAT will have many of these problems. It's not a coincidence that this practice test 8 had 10 of them. I chose this one at random. I haven't even looked at this practice test. I've done the other ones. I did a lot of work with 1 and 4 for whatever reason. I chose those two. And these keep popping up time and time again. Good luck on your SAT. I ask you to continue to math on. I will do the same. I'll see you in the next video.